Okay, so students, today we are going to talk about scientific notation. And I want you to know that scientific notation is the same as standard form. Okay? So we always write numbers in standard form when these numbers appear to be very big or very small. To write a number in scientific notation, it must be in a way that A times 10 to the power of n, where A is more than or equal to 1. Okay? It means that A is equal to 1 or bigger than 1, but it must be less than 10. Okay? Then also, this n is an integer. Okay? Remember, when we talk about integers, we said that integer can be positive. For example, 1, 2, 3, 4, 5, 6. It can be negative, -1, -2, -3, up to infinity, and it can be 0. Those are the integers. Okay? Now, let us look at an example. Let's have this as example number 1. So we are having a number, let's say, right, 5, 6, 8, 0, 0, 0. 5,680,000 in scientific notation. Okay? Remember, as we have seen, to write a number in scientific notation, we must have it as A times 10 to the power of n. A is a number that is greater than or equal to 1, but less than 10. And n is a number that is an integer. So our number is 5, 6, 8, 0, 0, 0. Now, first of all, we must make sure that this number is less than 10, but more than or equal to 1. So to do that, we will assume that we have a decimal point here. So we will move 1, 2, 3, 4, 5, and 6. So our answer, we have it as 5.68 times 10 to the power of 6. Now, 6, it is the number of times you have moved the decimal point. You can see 1, 2, 3, 4, 5, 6. And already you can see that this number 5.68, it is more than 1 and less than 10. So we say that this is our final answer. Okay. Let's have example number 2. Okay. This time, let's have 1,390,000. 1,390,000. Okay. Now we will have it as step 1. We need to make sure that this number is less than 10 and more than or equal to 1. So we have it as 1, 2, 3, 4, 5, 6. So the decimal point will get there. So we will have it as 1.39 times 10 to the power of 1, 2, 3, 4, 5, 6. So this will be our final answer. Okay. Now, let's have another example. We call it example number 2. Now, let's call it example number 3. Example 3. This time, let's have 0.000065. Okay. Now we say that this is equal to, remember, a number must be less than or equal to 1, but less than 10. So it means that we will move this decimal point 1, 2, 3, 4, and we put it here. Having it here, we will have 6.5. And we know that 6.5 is more than 1. So times 10 to the power of, you see, 1, 2, 3, 4, 5. So times 10 to the power of -5. Okay. So let's have another example. Let's call it example number 4. Okay. So now let's have 0.000008. Okay. Now we say that this is equal to, let's move the point 1, 2, 3, 4, 5, 6. So we have 8 times 10 to the power of -6. Now note that if you move the decimal point from right to left, you will have your power as positive. But if you move your point from left to right, you will have your power as negative. You have to note that. Okay. Let's have part 2, and we'll call it example number 1. We are going to write 218.5 times 10 to the power of 8 in scientific notation. Okay. So you can see that we are having 218.5 times 10 to the power of 8. So step 1, let's make this number less than 10, but more than or equal to 1. So simply we have to bring this decimal point up to here. So this means that we will have it as 2.185 times 10 to which power? You can see that we are moving from right to left. This means that the power will be positive. So the power of 1, 2 times 10 to the power of 8. Okay? So we use property 1 of exponents. Remember property 1 of exponents is that if we have a to the power of m times a to the power of n equals a to the power of m plus n. So it means that we are going to have 2.185 times 10 to the power of 2 plus 8. And then we get 2.185 times 10 to the power of 10. So this becomes our answer. I hope that is okay. Now, let's have example number 2. Let's have 0.0000, and let's have 3 zeros. 0.00047 times 10 to the power of negative 5. Okay, now we will move the decimal point. 1, 2, 3, 4. We put it here. So then our answer will be 4.7 times 10 to the power of negative, because you can see that we are moving from left to right. So 1, 2, 3, 4. Negative 4 times 10 to the power of negative 5. So this is equal to 4.7 times 10 to the power of negative 4 plus negative 5. So we come up with 4.7 times 10 to the power of negative 9. And that becomes our answer. Okay? All right. So we are going to get part 3. And we have example number 1. Let's have 5.5 times 10 to the power of 4 plus 0.032 times 10 to the power of 6. We need to write this in scientific notation. Okay? We write in scientific notation. Okay? Okay. So we are having 5.5 times 10 to the power of 4 plus, let's first write this to be equal to 1 or more than 1. So we will move this point 1 to 2 steps. So we have it at 3.2 times 10 to the power of 2. Negative or positive? Remember, we are moving from left to right. So this means that this will be a negative. Times 10 to the power of 6. So then we will have, let's first deal with this part alone. So this means that we will have it as 3.2 times 10 to the power of negative 2 plus 6. And this will be 3.2 times 10 to the power of 4. So it means that at this stage, we have 5.5 times 10 to the power of 4 plus 3.2 times 10 to the power of 4. Okay? Now you can see that you have 10 to the power of 4, and here you have 10 to the power of 4. So we can do it as 5.5, okay, plus 3.2 times 10 to the power of 4. And this will be, it will be 8.7 times 10 to the power of 4. And this will be our final answer. I hope you understand that. Okay, so now let's look at example number 2. Let's have 1.5 times 10 to the power of negative 5, okay, minus 0.02 times 10 to the power of negative 4. Okay, so now we can say that we have got 1.5 times 10 to the power of negative 5 minus, let's write this 0.02 as 0.2 times 10 to the power of negative 1. If you move one step, okay? Then times 10 to the power of negative 4. Okay? So we can have this as 0.2 times 10 to the power of negative 1 plus negative 4, such that we get 0.2 times 10 to the power of negative 5. So now it means that we will write 1.5 times 10 to the power of negative 5 minus 0.2 times 10 to the power of negative 5. Okay? Now, since we have 10 to the power of negative 5 here, and even here 10 to the power of negative 5, we can rewrite this as 1.5 minus 0.2 times 10 to the power of negative 5. Okay? And then we get 1.3 times 10 to the power of negative 5. So that will become our answer. Let's get example number 3. So let's have 1.2 times 10 to the power of negative 9, okay, times 1.5 times 10 to the power of 12. Okay, so you can see that both of these numbers, this alone is already in standard form, and also this one is already in standard form. But now we need to write the whole of it in standard form. So we say that this is equal to 1.2 times 1.5, okay, times 10 to the power of negative 9 plus, okay, let's first make it as times the whole of it, times 10 to the power of 12. Okay? So then we will have it as 1.2 times 1.5 times 10 to the power of negative 9 plus 12. Okay? And then we get 1.2 times 1.5, we get 1.8 times 10 to the power of 3. So you can see that this is in standard form. Okay? Now we will get the last example. We call it example 4. Let's have let's have 12.5 times 10 to the power of negative 6 divided by 2.5 2.5 times 10 to the power of negative 8. Okay, so we can change the way of writing it as we have it as 12.5 times 10 to the power of negative 6 divided by 2.5 times 10 to the power of negative 8. Still the same. So let's get 12.5 divided by 2.5. Okay, that will give us 5. And let's get 10 to the power of negative 6 minus negative 8. We are using property 2 of exponents. Okay, remember this will give you a plus, minus, and minus. So you will get 5 times 10 to the power of negative 6 plus 8. So that you get 5 times 10 to the power of 2. So this will be our final answer. So I hope that you have understood this very well.